relation to the circle? Miss Crystal.
We were outside.
There you go. Alrighty. Alright, so can everybody kind of agree that this is what we kind of looks like outside? Alrighty. So now, if you were one of the blues, we're going to say that you represented what we call a proton. A proton is a positively charged particle located inside the nucleus. At this point in time, we don't know what a nucleus is yet, but we'll get to that later in the presentation. So all you need to know right now is that the protons are inside of the nucleus. Does that make sense? Okay. And so now, the red ones, you represented what we call a neutron. A neutron is a neutrally charged particle located inside the nucleus as well. So if you notice, we have both protons and neutrons inside the circle of what we're calling the nucleus. Are there any questions so far? Yes, ma'am.
What does neutrally charged mean?
So we are going to get into the electrical charge in a later lesson, but right now you can just picture as it just having nothing. Like it's just neutral. Do you know what being neutral means?
Yes.
Okay, so kind of think of that right now, but that's a great question. We will get back to that in more detail in a later lesson. And then electrons, as you can see, are outside of this circle or outside of what we're calling the nucleus. And it's a negatively charged particle located in the electron cloud or outside the nucleus. And right now, electron cloud is a new vocabulary word, but we will get to that as well. So far, we've gone over that a proton is located where?
Inside the nucleus.
Thank you. And then an electron is located where?
Outside.
Yes, ma'am. And could someone else answer where is the neutrons located?
Inside the nucleus.
Thank you. Perfect. Alrighty.
Miss Ayala,
Yes, ma'am.
how do we know the charges, like how do we know that they're positive, negative? Like
Okay, yeah. So going back to what Zoe had asked earlier, what neutrally charged means. So right now, just know that we're focused on the location of these things that we're talking about. In a later lesson, right after this, we're going to go into what the charges mean. So what positively charged, what negatively charged, and what neutrally charged mean, okay? So right now, the focus is just the location. Okay, so now we're going to introduce to you what subatomic particle is. So subatomic particle is a particle smaller than that of an atom. And I know we haven't covered what an atom is yet, but if you notice, we're starting small and we're building up to that. So the subatomic particle are the protons, neutrons, and electrons that we just talked about. Okay? So where are the protons located?
inside.
Inside nucleus. Where are the neutrons?
Inside.
And then electron.
Outside.
Perfect. And all of those are what we consider to be subatomic particles, or partículas subatómicas. Okay, so the models that we were just doing, so the nucleus circle with like the footprints and everything like that, did that look familiar to anybody? Like, does it relate to anything that you might already know about, or just anything? What does it look to
To
you?
the solar system.
Okay, and then what is similar between that and the solar system?
The sun is the nucleus.
Okay.
The middle, and then the planets can be the electrons.
Okay, because they're outside of it? Alright, perfect. Anybody else have any other examples? Okay. So yeah, so this is the example that we were using, the solar system. So exactly like Crystal said. So we have the middle portion and then we have all the things circling around it. Okay, so now this is a version of the model that we were just looking at, but instead of using footprints, we're using these big circles instead. And so something to keep in mind that with the footprints, they didn't take up the entire nucleus, correct? They didn't take up the entire circle. But with that the subatomic particles, so the protons and neutrons, they take up the entire circle. So the circle or the nucleus is not actually filled with space, but it's actually filled with these subatomic particles. And so like we already mentioned, the nucleus is this outside portion. And so the nucleus, or the nucleo, is the central part of an atom. And so like I mentioned, we still haven't caught on what an atom is yet, but start putting together all these things and building it into that. So we have the subatomic particles, and now we have the nucleus, okay? Yes, ma'am?
So I know we're not going over atoms yet, but are the green circles the electrons?
Yes, ma'am.
Are those outside of the atom, or are they also part of the atom?
So they're going to be part of the atom, and so right now, we're just looking at the location in relation to the nucleus itself.
Okay, so is the whole slide then the atom?
Yeah, you can look at it like that.
Okay.
Yes, thank you. Yes, ma'am.
This may not be related or off topic.
You're
but
okay, go ahead.
How do scientists know that an atom is positive and neutral on the inside, like in terms of charges? Does that relate to mathematics, or like how can you know that if you can't see an atom?
Okay. Yeah, so atoms aren't visible to the naked eye. And so in order to be able to actually like see the inside, we have to use special technology. And so unfortunately, that's not what we're doing right now. So we won't actually get to see that portion of it. And so that's why we do have to use, these types of visuals and models in order for us to actually understand the concept. Does that make sense?
So later on in the lesson, will we know how something abstract?
Yes, so later on, like I said, we're just focusing on location right now. So in a lesson later, we are going to actually go deep into the electrical charges, and that includes the positive, negative, and neutral.
Thank you.
Okay, and so now we're going to look at the electron cloud. And so we had already mentioned that the electrons, I forget I have a laser, the electrons are outside of the nucleus, right? And so now we're introducing the electron cloud, or the nube de electron. And so the electron cloud is just the space located outside of the nucleus. And as you can see, we now have like these little like circles going around it. So it's almost kind of like it's orbiting. So if you remember, we said that this model is similar to that of the solar system. And so all the planets have their like little orbits, correct? And so this is very similar to that, where the electrons, they have their orbits that go around the nucleus. And so the electron cloud is all of this space that the electrons orbit around. Yes, ma'am?
Do electrons ever move into the nucleus, or do they always stay?
They will always stay outside the nucleus. So if you remember our definition of the electrons that we discussed earlier, it's a particle that's outside of the nucleus.
Okay.
Yes, ma'am?
Are the electrons, when they're going around, are they going to go around in a circle, or will they ever like cross each other?
That is a great question. I'm glad you asked that. Keep that in mind for later in the lesson, okay? So just to go over the definition, it's the electron cloud is a system of electrons surrounding the nucleus of an atom. So all of this. Okay, so like I was mentioning earlier, we haven't gone over, the big part of this yet. But what does all this make? So all the subatomic particles, the nucleus, the electron cloud, does anybody have a guess of what this all makes? Yes?
An atom?
Yay! Perfect! An atom! Okay, and so if you look, this entire thing is an atom. And so, Crystal, do you remember your question about if it's just a circle, if it goes all like that? So we're just showing like 2D models because that's what makes sense, to us to look at. But if you see this, like it goes all craziness, right? So an atom, or an atomo, is the basic unit of an element. And so if you remember back to 6th grade, we went over what an element was. And so the atom is the basic unit that creates that element. And so our subatomic particles that we've already covered, protons, neutrons, and electrons, they make up an atom. Okay, so first, are there any questions that we haven't covered yet?
So atoms are found everywhere, even in the air?
Mm-hmm. Yes, ma'am. Okay, so now,
Wait, I have a question.
yes,
Do atoms weigh anything?
that is a great question, and I like your thinking. Like I said, we're not focused on the atoms specifically right now.
Okay.
We are just looking at the locations of the different subatomic particles, and so we will get to your question though later in the event.
Okay.
If you now, hopefully, as you're watching this video, try to connect it with what we just covered through our slideshow and through like the models and everything.
Make up atoms. Each atom has a dense center called a nucleus. The nucleus contains neutrons, which have a neutral electric charge, and protons, which are positively charged. The number of protons in an atom determines an element's physical properties. No two elements have the same number of protons. Revolving around the nucleus like planets around the sun are negatively charged particles called electrons. Electrons and protons attract.
So, Crystal, your question earlier, notice all the different rotations that the electrons are, going through. Like it's not just flat and circular.
Each other. So atoms usually have equal numbers of the two particles.
Okay. And so then that continues to go on to things that we will be talking about. But for now, did everybody see just like the locations of what we talked about? Okay. And then, I don't know where the actual slideshow went, but just one last question. What were some differences? We already covered this, so I just want to, put the pieces together. But what were some differences between what we saw in the video, like how everything traveled, and what we saw just in the model outside and the pictures we showed? Yes, ma'am.
You don't see the intersections of the electrons because they're moving crazy instead of just are found around our ring.
Yeah, perfect. So another kind of term that came to mind when I was looking at it was the difference between 2D versus 3D. So in the video you could really see the 3D, kind of motion of it, whereas just on pictures and stuff we just saw the 2D stuff. Okay. Looks like you have a question.
Kind of. So on the video, does the nucleus, is it defined or is it just where we see the protons and neutrons?
So the nucleus is it's a part of the cell. And so I know we didn't cover cells, but in 6th grade you should have covered, the parts of the cell, correct?
Mm-hmm.
And so just the nucleus is just part of that cell, and what's inside of the nucleus is where we find the protons and neutrons.
So I guess my question is it just going to be where I see that and it's not going to be defined and have a circle around it?
So it's just the protons and neutrons. There's not a definite circle.
Okay, so just where those,
That
Yeah.
cluster.
that cluster, that's the nucleus.
Yes, so that misconception that we addressed earlier, how in the footprints, there's all this space in between all the footprints. But in the actual nucleus, those subatomic particles, they take up the entire space. It's not just, the full space.
Okay.
Yes, ma'am.
When you're pairing the electrons around, are you gonna have to separate them, or are you gonna pair them together, for them to equal out?
Equal out what? What have we gone over any of that yet?
Well, it said in the video about balancing or
Yeah.
something. So, do the electrons balance with the center nucleus?
So I like where you're thinking, but just keep in mind we're just looking at location right now. And so once we get, an idea of the locations, we're good on that part. And then later, that's when we'll get, you know, more into detail about the electrical charges as well as like the whole balancing thing, and that will make a lot more sense then.
I have a question. On the video, you showed that the green particles were small, but on your slide, it was the same size. So is there a size difference?
Maybe. We'll learn about that later. Right now we're just focusing on the location.